as promised, examples of the three main types of index equation and how you solve them. So first of all, nice easy one here. The index is an index equation because the x is up here. It's not to the power of 5, it's 5 to the power of. So we need to release this x add 2 from this equation. So we do that by doing the opposite of 5 to the power of, which as we know is log to base 5. So we've now done log to base 5 to both sides, and that's released this x add 2 down from being an index, and then obviously we can just quickly take that 2 off there, and that's the end. We've got x. Be careful not to do 4 minus 2. It's not log to base 5 of 4 minus 2, it's log to base 5 of 4 minus 2. This is a number in its own right. It's a bit like if you have the square root of 5 take away 2, that does not equal the square root of 3. So don't try and combine these two together like that. Okay, this one a little bit harder because you've got x up here, so you want to do log to base 3 to release that, but you've also got x's up here, so you want to do log to base 5 to release that. Now you can do log to base 3 to both sides and fiddle around and it will work. You could do log to base 5 to both sides to release this and then fiddle around and it will work, but the easiest thing to do is to do log to base 10 to both sides. So if I do log to base 10, I don't need to write 10 at the bottom, I can just write log and everyone knows I mean log to base 10. So I've got log to base 10 of that side and log to base 10 of that side. So I've done the same thing to both sides. Now I can use that nice rule to pull these powers down the front. So we've got x log 3 equals x minus 1 log 5. Make sure that you put brackets around this, x minus 1, because otherwise it says x minus 1 log 5, and that's not what you mean. You mean x minus 1 lots of log 5. That whole power comes down. Now this is just a number, log 3, and this is just a number, and we know from GCSE how to expand out brackets. So on the right hand side we've got x lots of log 5 minus 1 lot of log 5. And just again using all the normal things from GCSE, get all your x's on one side, x log 3 minus x log 5 equals minus log 5. Factorise by pulling x out on the left. And then divide this underneath. And then you can just use your calculator because it's got a log button on it. So you can just use the log button on your calculator. So that's a good, nice method for solving that sort of equation. It's not the only method, but it's a nice one. Right, this type of equation, this is the hardest type. And to solve this type of equation, you're going to need these two rules of indices, which usually you see written the other way around. You normally see x to the a all to the b is x to the ab, and x to the a times x to the b is x to the a plus b, but I'm going to use them in this direction rather than in this direction. So for example here, you can see 3 to the x add 1. So if you look at this index rule here, you can see that the x is now a 3, and the a is now an x, and the b is now a 1, so I can use this rule to write this like this. So this middle bit here, I can write minus 3 to the x times 3 to the 1, and then multiplied together. Add 1 is 0, so I've just got this bit to deal with now. Now this bit here, 2 we don't need to worry about, but the 3 to the 2x, this is the same as this, where x is 3, 2 instead of a, x instead of b. So you can see that I can pull this apart by saying that this is x to the a all to the b. So I could write this one as 3 to the 2 all to the power of x, and then I could have that 2 in front there, or because 2 times x is 2 times x, or what would be actually better for this situation is to write it as 2 to the x all to the power of 2, because x times 2 and 2 times x are both 2 times x, it doesn't matter which way round they are. So here x to the a all to the b is x to the ab, but x to the b all to the a would also be x to the ab, because these two multiplied together, doesn't matter which way round they are. So the reason I've done it like this is because I want to write y here instead of 3 to the x. So I'm just going to write y instead of 3 to the x now and see what it looks like. So I've got 3 to the x squared, so that's y squared, and I've got 2 of them. And I've got y times 3 here. Y times 3 is 3y. And now it's a nice quadratic. So now we can just solve this quadratic quite easily, hopefully, with factorising. So we've got 2y minus 1 and y minus 1, I think. 2y squared, take away 1, take away 2, add 1 there. So this gives us y is a half, or y is 1. But we have to remember that y is actually 3 to the x, and it's actually x that we want. So we know that y is a half and y is 1. So y is 3 to the x. We know that 3 to the x is a half, or 3 to the x is 1. These are the things that we know now. So now we need to solve these equations to get x. But this is the same as the very first example that I did, where all we need to do is release this x from this situation. X is the index. So what we're going to do is the opposite of 3 to the power of, which is log to base 3. So that's released the x from that one. And again, here to release the x, log to base 3. But you should know that log to base 3 of 1 is always 0. So your final answers are x is 0, or x is log to base 3 of a half. And that pretty much covers the main examples that you need to know for indices. Not indices, yeah, indices.